Hello everyone, engineering statistics and linear algebra. We have started module number 2. In last 3 videos, all these concepts are discussed. It would be better if you have watched the previous videos, and I could suggest you to watch them to understand the following concepts in better way. Today's discussion is calculation of a bivariate CDF from a given bivariate PDF. A bivariate PDF is denoted as f, a small f, and here it is given as the bivariate PDF is 0 everywhere outside of a unit square with the corners 0, 0, 0, 1, 1, 0 and 1, 1. The bivariate PDF has a constant value of 1 within the unit square. Mathematically it is defined here. Bivariate PDF is 1 if x and y's are varying from 0 and 1. It is 0 otherwise. Graphically it is denoted as bivariate PDF is 0 outside this unit square. Outside the unit square it is 0, and inside this unit square the bivariate PDF is 1. For bivariate PDF, let us calculate, examine the bivariate CDF in 5 different regions in the XY plane. Regarding these 5 different regions you will come to know in the following slides. The second point is determine marginal densities. They are nothing but fx of x and fy of y, that is a single random variable probability density functions. Then third point is are x and y independent. Alright, first calculation is examine the bivariate CDF in 5 different regions in the xy plane. Consider the region 1. XY is to the left of the y-axis and below the x-axis. Consider the XY plane. Consider the given bivariate PDF in XY plane. And let us consider the region number 1. It is what here the shaded area that defines the following statement. This shaded area is existed to the left of y-axis and below the x-axis. Left of y-axis and below the x-axis. In this area, let us calculate the cumulative distribution function. The bivariate cumulative distribution function in this shaded area is 0 because this is always 0 here. Because in this shaded area, the probability density function is 0 here. It is the reason existed outside the unit circle. Outside the unit square. Outside the unit square, the value of bivariate PDF is 0. So a bivariate PDF is used to calculate a bivariate CDF. Bivariate CDF can be calculated by integrating a bivariate PDF with respect to x and y. A bivariate PDF in this shaded area it is 0. Integration of 0 gives the value 0. As a conclusion, in region 1, a bivariate CDF for a given bivariate PDF is 0 here. Let us go for reason number 2. A reason whenever a xy is to the right of x and y equals to 1. Consider the xy plane and the bivariate PDF. In this xy plane, consider the reason such that x and y should be the reason it should be right of x and y equals to 1. This will be the reason here. This is the reason existed right of x equals to 1 and right of y equals to 1. In this reason, CDF is 1 because the unit square is always included in the integrand. Because of x and values of x and y's are 1 here, so that x and y's are varying from 0 to 1. If this is the case, means always this unit square is included in the integrand. The value of this unit square over the range 1 is 1. So as a result, integration of 1 into dx gives the value x. Integration of 1 into dy gives the value y, and apply the limits 0 and 1. This we will simplify this, we will get a value 1. So a bivariate CDF for a given bivariate PDF in reason number 2 is 1. The reason number 2 is existed at right of x and y equals to 1. In this reason, a bivariate CDF is 1 here. Alright, let us consider reason number 3. It is a strip. Whenever x and y is in this strip, y is greater than 1 and x is varying from 0 to 1. Consider xy plane and the bivariate PDF. The reason number 3 is a strip. This strip is existed where y is greater than 1 and x is varying from 0 to 1. Y is greater than 1 means this is the point and onwards, and x is between 0 to 1 means origin to the second corner point. So this will be the reason number 3. It is considered as a one strip. In this strip, calculation of a bivariate CDF should be done here. In this strip, a y is varying from 0 to 1 and x is varying from 0 to x. So after calculation, after simplification, the value will be x. Integration of dx is x and values are varying from 0 to x. Integration of dy is y, limits are varying from 0 to 1. After simplification, it will be 1, it will be x, 1 into x will be x. In reason number 3, the bivariate CDF for a given bivariate PDF is what? X. Consider reason number 4. It is also a strip, but the condition is strip where x is greater than 1 and y is varying from 0 to 1. XY plane, a PDF is considered here. Reason number 4 is a strip where x is greater than 1, yes it is there, and y is varying from 0 to 1. In this strip, the calculation of a bivariate PDF should be done. So it can be calculated using this formula where x is varying from 0 to 1 and y is varying from 0 to y. So integration of dx is x, integration of dy is y. Apply the limits, do the simplification, we will get a bivariate CDF in this strip as a y. Let us consider the number 4. xy, it is a unit square and values of x and y's are varying from 0 and 1. This is a xy plane and the PDF, bivariate PDF is considered. Reason number 5, where x and y's are varying from 0 to 1. As a result, this will be the reason. In this reason, what would be the value of bivariate CDF? It will be xy. Because x is varying from 0 to x, y is varying from 0 to y. So after simplifying, a bivariate CDF in this region would be xy. Right. Let us summarize all this discussion. Calculation of a bivariate cumulative from a bivariate probability density function in 5 different regions. These are 5 different regions. In 5 different regions, these will be the values. It is a XY plane where bivariate PDF is given. Consider the region left of y-axis and below the x-axis. In this region, a bivariate CDF is what? A 0. Now, consider the region within the unit square where x and y's are varying from 0 and 1. In this range, a cumulative distribution function will be xy. Consider the strip. Consider the strip where y would be greater than 1 and x is varying from 0 and 1. In this case, the bivariate CDF is what? X. Consider the one more strip where x is greater than 1 and y is varying from 0 and 1. In this region, the value of bivariate CDF is y. And the region where x and y's are greater than 1. In this region, the value of bivariate CDF is what? 1. So, 5 reasons. Reason number 1, 2, 3, 4, 5. In all these reasons, value will be different. 0, 1, x, y and xy. Right. Let us calculate marginal densities for a given a bivariate PDF. Fx of x and fy of y are nothing but a marginal densities here. That is single random variable probability density functions. Fx of x can be calculated using a bivariate probability density function by integrating a bivariate PDF with respect to dy. And y is varying from 0 and 1. In that range, a bivariate PDF is 1. After simplification, the result is 1. This one can also be written as y, but condition is what? Y is varying from 0 and 1, 0 to 1. Similarly, a marginal density fy of y, it can be calculated by integrating a bivariate PDF with respect to x. So where x is varying from 0 and 1, and in that range bivariate PDF is 1. After simplification, we'll get fy of y as a 1. This one can also be written as x, but condition is x is varying from 0 and 1. Alright. Are x and y independent? Yes, bivariate random variables are independent in nature because a bivariate PDF equals to a product of individual PDFs here. We have calculated bivariate PDF as xy and single random variables probability density function as xy. This is done by considering x and y values. They are varying from 0 and 1. So LHS equals to RHS here, so that we can say that bivariate random variables are independent in nature. Based on that concept, let us solve the one more same problem where the magnitude is 1 by 4 instead of 1. Everything will be same. So bivariate PDF is 0 everywhere outside of the unit square with the corners 0, 0, 0, 1, 1, 0 and 1, 1. And the bivariate PDF has a constant value of 1 by 4 within the unit square. So graphically, this bivariate PDF is denoted here. For this given PDF, let us calculate. Examine the bivariate CDF in 5 different regions in the XY plane. Determine the marginal probabilities or marginal densities. Are x and y independent? The first calculation is here A. The bivariate PDF in this example may be written as using two-dimensional delta functions. This is what a given our bivariate probability density function. This bivariate PDF should be written in terms of unit delta function. It consists of four corners. In those four corners, the magnitude of each corner is 1 by 4. The point at the origin can be written as 1 by 4 into delta x and delta y. The first corner in terms of unit delta function can be written as 1 by 4 into delta x into delta y. Second corner, here delta x is a shifted version here. It is a shifted right side by 1 unit. It can be written as delta of x minus 1 into delta of 1 by 4. Here y is a shifted version here. Shifted 1 unit right side, so that it can be written as y of minus 1. Then third point, both x and y's are shifted versions, so that the fourth corner can be written as 1 by 4 delta of x minus 1 and a delta of y minus 1. So as a result, the given bivariate PDF, the given bivariate PDF can be written in terms of two-dimensional unit delta function as it is a sum of all these functions. So this will be the result. This will be the first step for this given problem. So next step is, let us calculate a bivariate cumulative distribution function for a given probability density function. This is the reason. Consider the bivariate PDF and consider the reason, and it is left of y-axis and below the x-axis, and in this reason the bivariate CDF is 0 because integrand is always 0 here. The reason is, in this reason the bivariate CDF is 0. It is outside the unit circle, unit square. So in this shaded area, the bivariate PDF is 0. Integration of 0 is what? 0 here. And reason number 2, whenever xy is to the right of x equals to 1 and y equals to 1, consider the xy plane and a bivariate probability density function. Reason 2 will be this. In this reason, the bivariate CDF is 1 because the unit square is always included in the integrand. As a result, a bivariate CDF in reason number 2 is 1. So in reason number 1 and 2, results will be certain. They are always same. Now, let us consider reason number 3. So it is a strip where y is greater than 1 and x is varying from 0 and 1. In this strip, out of these 4 functions, 2 will be 0. X is varying from only 0 and 1, but second and fourth functions will be after x is equals to 1. After x is equals to 1, delta of x minus 1 will be 0. 0 is multiplied with anything is 0, so that second and fourth term will be 0 here. The reason is we have considered the value of x which is varying from only 0 and 1. As a result, a bivariate CDF can be calculated by considering first and third functions here. 1 by 4 delta of x into delta of y plus 1 by 4 into delta of x into delta of y minus 1. 1 by 4 and 1 by 4, they are constant, they have taken outside. And we know one identity, integration of unit delta function gives a unit step function. Always unit step function is 1. Integration of delta x, integration of delta of y equals to u of x and u of y. 1 into 1, that gives 1. So from these terms only 1 by 4 will be remaining. From these terms only 1 by 4 will be remaining. It becomes 1 because integration of delta of x and integration of delta of y minus 1 is unit step signal. Its value is always 1. So 1 by 4 plus 1 by 4 equals to 1 by 2. In reason number 3, for a given bivariate a probability density function, the bivariate cumulative distribution function will be 1 by 2. Let us consider the reason number 4. It is a strip where x should be greater than 1 and y is varying from 0 and 1. Because of these conditions, again two more functions will be 0. Let us consider third and fourth functions here. In the third function, delta of y minus is considered. This value will be 0 if this is the limit. Here y is varying from only from 0 and 1, but this is the signal existed after y equals to 1 and onwards. But we have considered this range so that this term will be 0. If it is 0, third term will be 0, and also the fourth term will be 0. So that in this strip only first and second functions will become. And let us calculate a bivariate cumulative distribution function where x and y's are varying from x is greater than 1 and y is from 0 and 1. So similar to reason number 4, 1 by 4 and 1 by 4 are the constant. Integration of delta x, integration of delta y gives a u of t that is equals to 1. Similarly, this term will become 1. So 1 by 4 plus 1 by 4 equals to 1 by 2. In reason number 4, bivariate cumulative distribution function for a given bivariate probability density function is 1 by 2. Let us consider reason number 5. So where x is varying from only 0 and 1 and y is varying from 0 and 1. Because of this condition, because of this limit, second term will be 0 because we do find here shifted version of delta x, it is 0. We do find here a shifted version of y. Because of this limit it will be 0, and fourth term both are shifted so that 0. Only first term will be remaining in this region. So this is what the reason. In this region, let us calculate a bivariate CDF. Out of 4 functions, 3 functions are neglected here because they are 0, because this is the limit. So 1 by 4, what will be the value of these terms? Integration of delta x, integration of delta y gives u of x and u of y, that will be 0. Sorry, that will be a value 1 because of this identity. As a result, bivariate CDF in reason number 5 is what? 1 by 4. Fine. So we have discussed and we have calculated bivariate CDF in 5 different reasons for a given a bivariate PDF. So it is 0 in this reason, and in this reason it is 1 by 4, and consider the next reason. In this reason it is 1 by 2. Consider one more strip where a bivariate CDF is 1 by 2. Consider the one more reason. In this reason, x and y's are greater than 1. Its value is 1. And what is the value of CDF, bivariate CDF in this reason? It is 0. Okay. So can we say that it is a given bivariate PDF? See here. Bivariate PDF, its value equals to 1 by 2 only if x and y's are varying from 0 and 1. You can observe here. We have said 4 corners. It is 3-dimensional view and it is 2D. This first corner, it is what 1 by 4. This is the first corner. Its value is 1 by 4 here. And second corner, x is a shifted version here. This is x-axis. This is y-axis. First corner, second, third, and fourth corner. In all these corners, the value of a bivariate PDF is what? 1 by 4. For such a bivariate PDF, we have calculated a bivariate CDF. So for this bivariate PDF, a bivariate CDF could be 0, 1 by 4, 1 by 2, 1 by 2, 1 in 5 different regions that we have calculated here. It is what a 2D view of the calculated bivariate CDF, then how it looks in 3-dimensional. In this region, is it 1 by 4? Yes, yes, you can observe here. X is varying from 0 to 1, y is varying from 0 to 1. So this will be the square box. What could be the value of it? 0.25. 0.25 means 1 by 4. Alright. If x and y is, if y is left off, if the point is left of y and below the x-axis, this will be the reason left of y and below the x-axis. Do you find any value of CDF here? No, it is 0. And what could be the value of bivariate CDF in this strip? It is 1 by 2. What x, that is what x is varying from. X is varying from, x is greater than 1 here, from 0 is varying from 0 to 1. So it will be the value here. In this strip, the value is 1 by 2. And this strip, a bivariate CDF is 1 by 2. Then do you find this as a 1 by 2 here? X-axis, y-axis, 1 by 4, 1 by 2, 1 by 2, and it is 1. It is 1 here. And where is 0? In all these regions where x and y are less than 0. So this value is 0 here. So this is what today's discussion. So for a given bivariate PDF, then how to calculate a bivariate CDF and calculate a marginal densities. That is what fx of x, and how to calculate this fx of x, integrating bivariate PDF with respect to dy. So because of this, 1 by 4 and dx will be constant because these are integrated with respect to dy, so that 1 by 4 into delta x is taken outside. It acts as a constant here, and 1 by 4 into delta of x minus 1 is a constant. 1 by 4 into delta x, 1 by 4 into delta of x minus 1 is a constant. Then integration of delta of y into dy, it is nothing but u of y. U of y is what? 1. Similarly, integration of dy into, integration of delta y into dy is what here? U of y, that gives 1, and so on. As a result, so 1 by 4 into delta x, 1 by 4 into delta x is equal 1 by 2. 1 by 4 plus 1 by 4, 1 by 2 into delta x. It is what? Fx of x. Similarly, Fy of y, integrate a bivariate PDF with respect to x. As a result, delta y and 1 by 4 will be constant here. The reason is these functions should be integrated with respect to delta x here. As a result, 1 by 4 and delta y terms will be a constant. And we do use the identity integration of delta of t gives u of t, that is equals to always 1. As a result, these terminals will be there. After simplification, we will get Fy of y as this term. So marginal densities fx of x and Fy of y are calculated here. Based on that calculations, are x and y independent? Yes, bivariate random variables are independent in nature because of a bivariate PDF equals to multiplication of individual PDFs here. So bivariate PDF is given and we have calculated fx of x and fy of y. Fx of x, it is what fx of x, and it is what fy of y. So consider neglect the term y here and neglect the term x here. It is fx of x, it is fy of y. If these two are multiplied, then we will get a bivariate PDF. Because of that reason, we can say that x and y are independent in nature. So this is what today's discussion. In next class, we will solve some more problems on the concept. So like, share, comment on the videos and subscribe the channel for the further videos and make this online teaching so interactive. Thank you.